Okay, dear students, today we will solve the numericals of chapter 14, Refraction of Light, page number 315 to 316. But only one topic left, that is power of lens. It is the reciprocal of focal length in meter. It is called power of lens. Means we have to find out the power of lens. We will use this formula. P is equal to 1 upon F. 1 upon F, F means focal length in meter. And its unit is diopter. Otherwise, the unit of power is watt. But here the unit of power of lens is diopter. You have to learn it. Diopter. Now we will start numerical. So first numerical 14.1, its data is V1 is equal to 3 into 10 raised to 8 meter per second. V1, we will take the speed of light in air, that is fixed, 3 into 10 raised to 8 meter per second, and V2 is the velocity of light in glycerine. In other medium means glycerine, water, glass, these are the other medium. So refractive index is 1.47. Our formula is, you have read about that n is equal to V1 upon V2. V1 is the velocity of light in air, that is fixed, constant. But V2 is other medium. Now refractive index is 1.47, n is equal to 1.47, V1 is equal to 3 into 10 raised to 8, and V2 you have to find out. Now V2 is equal to 3 into 10 raised to 8 upon 1.47. By calculation we will get 2.04 into 10 raised to 8 meter per second. It is the velocity of light in glycerine. This is your answer. Next, numerical number 14.2. V1 is equal to same, that is constant, velocity of light in air, 3 into 10 raised to 8 meter per second. V2 is velocity of light in water, 2.25 into 10 raised to 5 kilometer per second. Now you will change the kilometer into meter, because in SI system the unit of length or distance is meter. You have to change it into meter from kilometer to meter. 1 kilometer has 10 raised to power 3 meter. So you will multiply it from bigger unit to smaller unit. By multiplying 2.5 into 2.25 into 10 raised to 8 meter per second. These powers are added, it becomes 10 raised to power 8 meter per second. Now you have to find out n, refractive index. Again the same formula, n is equal to V1 upon V2, n is equal to V1 is 3 into 10 raised to 8 and V2 is 2.25 into 10 raised to 8. 10 raised to 8 and 10 raised to 8 cancel. By calculation, this refractive index becomes 1.33. So the refractive index of water is 1.33. This is your answer. Now next, numerical number 14.3. Angle I is 40 degree and angle R you have to find out, and n is equal to 1.33. Angle I means angle of incident of light through water is 40 degree. You have to find out the angle of refraction. Refractive index of water is 1.33. Your formula is, according to the Snell's law, n is equal to sine angle I sine upon sine angle R. N is equal to 1.33 and sine angle I is 40 degree. So sine angle R you have to find out. Now sine angle R is equal to sine angle 40 degree upon 1.33. You have to find the value of sine angle 40 degree in the log table or with the scientific calculator. Put this value of angle, that is 0.6783. When you will divide the value of sine 40 by 1.33, it will become 0.6783 almost. Then angle R, you have to find the value of sine 0.6783. So the value of sine is 28.90 degree. This is your angle of refraction. Now numerical number 14.4, f is equal to 10 centimeter, mean focal length is equal to 10 centimeter. Magnification of image is 2, and you have to find out the position of the object, that where you have placed the object in front of the convex lens, and q is equal to, you have to find out. Now you will apply this formula, m is equal to q upon p for the magnification, and second formula for the value of q and p, you will find 1 upon f, 1 upon p plus 1 upon q. Now m is equal to q upon p. Instead of m you will write 2, because magnification is 2, q upon p. By cross multiplication, q is equal to 2p. Now apply the formula, 1 upon f is equal to 1 upon p plus 1 upon q. 1 upon f, 1 upon 10 is equal to 1 upon p. Instead of q, you will write 2p. You will take the LCM of p and 2p, it will become 2p. So 2p is divided by p, so 2 is multiplied by 1, 2, then plus, then this denominator also divide the LCM, it will come 1, so 1 ones are 1, 2 plus 1. It comes 1 upon 10 is equal to 3 upon 2p. Now by cross multiplication, 2p is equal to 10 3s are 30 and p is equal to 30 upon 2. So the position of the object from the lens is 15 centimeter. This is for real image. For virtual image, 1 upon f is equal to 1 upon p plus 1 upon q. 1 upon 10 is equal to 1 upon p minus 1 upon 2p, because for the virtual image the value of q is negative. For the virtual image, value of q is negative. Therefore we will put this sign, instead of plus we will write minus. So by getting the LCM, it comes 2p. Then again same process, this denominator divide the 2p, 2 ones are 2, like 1 ones are 1, 2 minus 1. Then 1 upon 10 is equal to 1 upon 2p. By cross multiplication, 2p is equal to 10 and p is equal to 10 upon 2. So p is equal to 5 centimeter. This is your answer. Next, numerical number 14.5. You have to find out the focal length, in which p is equal to 5 centimeter distance of the object, and q is equal to 10 centimeter distance of the image, and the image is real. When image is real, then the q is positive. If the image will be virtual, then q will be negative. So by applying this formula, 1 upon f is equal to 1 upon p plus 1 upon q. 1 upon f is equal to p is 5 and q is 10. We will take it minus. Why? Because we are getting virtual image. So LCM is 10, 5 and 10. LCM becomes 10, 5 to the 10, 2 ones are 2, 10 ones are 10, 1 ones are 1, so 2 minus 1 is equal to 1 upon 10. F is equal to 10 centimeter by cross multiplication. For virtual image, the focal length of convex lens is 10 centimeter. Real image. Now we have to find out the real image, distance of the focal length of the lens for real image. P is equal to 30, then 1 upon F is equal to 1 upon P plus 1 upon Q. Because image is real, therefore we will get it plus. 1 upon F is equal to 1 upon 30 plus 1 upon 10. LCM of 30 and 10 comes 30. So 1 plus 3 is equal to 4 upon 30. And 1 upon F is equal to 4 upon 30. By cross multiplication, F is equal to 30 upon 4. We will get 7.5 centimeter answer. Next, 14.6. Focal length of the lens is 1 meter and the object is placed at 2 centimeter. So F is equal to 1 meter, P is equal to 2 meter, and you have to find out the Q, means distance of the image, and also magnification M. Now 1 upon F is equal to 1 upon P plus 1 upon Q. 1 upon 1 is equal to 1 upon 2 instead of P plus 1 upon Q. Now 1 upon Q is equal to 1 upon 1 minus 1 upon 2. 1 upon Q is equal to 2 minus 1, 1 upon 2, and Q is equal to, by cross multiplication, 2 centimeter. This is your answer. Next, magnification is equal to Q upon P. Now, Q is 2 and P is also 2. It comes 1. 1 means same size of the image as the size of the object. This is your answer. Next, 14.7. The object is placed in front of the convex lens and its image is formed at this screen. So the distance between the object and image is 49 centimeter. We know that the distance of the object from the lens is P and distance of the image from the lens is Q. So when we will add P plus Q, that becomes 49 centimeter. That's why we will write it P plus Q is equal to 49 centimeter, and magnification is 6 times, and F you have to find out. Now we will apply the formula M is equal to Q upon P, 6 is equal to Q upon P, and by cross multiplication Q is equal to 6P. Now put this value in this equation. Instead of Q, you will write 6P because this is the value of Q. P plus Q is equal to 49. P plus 6P is equal to 49 and 7P is equal to 49 and P is equal to 49 upon 7, that is 7 centimeter. So the P value of P is 7 centimeter. Again we will apply this equation that P plus Q is equal to 49. The value of P is 7. We will put here 7. 7 plus Q is equal to 49 and Q is equal to 49 minus 7. Q is 42 centimeter. Now apply this formula. 1 upon F is equal to 1 upon P plus 1 upon Q. 1 upon F is equal to, instead of P you will write 1 upon 7, instead of Q you will write 1 upon 42. By getting LCM it is 42, then 6 plus 1 is equal to 7 upon 42. By reducing it, it comes 1 upon 6. By cross multiplication, F is equal to 6 centimeter. So the focal length is 6 centimeter. Next, 14.8. P is equal to 18 centimeter and F is equal to minus 6. This is concave lens because the focal length of concave lens is in negative. So minus F mean F is equal to minus 6. In your book it is written as convex lens, that is misprinting. You will change it into concave lens according to the answer of the book. If you will not change it, you will do it with the convex lens, then this answer will be 9 and this answer will be 50. So if you want to get that the answer should be same as the book, then you will change this lens. This is concave lens. So by applying this formula, 1 upon f is equal to 1 upon p plus 1 upon q. Now 1 upon f mean 1 upon minus 6 and p is 1 upon 18 plus 1 upon q. Now 1 upon q is equal to 1 minus 1 upon 6 minus 1 upon 18, or 1 upon q is equal to minus 1 upon 18 minus 1 upon 6. So 1 upon q is equal to minus 1 minus 3 upon 18. It comes minus 4 upon 18 by calculation, and by cross multiplication q is equal to 18 upon minus 4. So the value of q comes minus 4.5 centimeter. If the value of q is minus, then the image is virtual. Image will be virtual and value of q is minus 4.5 centimeter. For the magnification, q upon p is equal to minus 4.5 by 18. Now divide 4.5 by 18, you will get 0.25 times. So the magnification image is 0.25 times, and the image is virtual, and the distance of the image from the concave lens is minus 4.5 centimeter. So this is the end of this chapter with numericals. Now you have to learn the formula and write down all these numericals and try to understand it and do it at yourself on your copy. When you will come to school up to 14th chapter, your copy must be complete. Okay, thank you.